We're discussing how to draw publication quality graphs and plots with Origin Pro. In the same line, we have already discussed in our previous section how to draw bar graphs and how to draw bar graphs with error measures. Let us now continue and see how we can draw scatter graphs in Origin Pro. These are some examples of scatter graphs that I have drawn in Origin Pro, and I'll show using the Origin Pro how the same can be drawn. So scatter graphs basically tells us some information about some data uh, which is organized in a very random manner in a particular space. So let us first try to see this particular diagram. In this diagram, what happens is that suppose say I have experimentally measured the hardness of a particular coating, and the same hardness has been predicted by using some technique, some artificial intelligence technique, and now we are trying to find a correlation between these two, and we are trying to see that how well the artificial intelligence technique has predicted the experimental hardness. So basically we are plotting the experimental hardness with the predicted hardness here. So this is one form of scatter plot that we can use. So basically what we have done is that we have used the same uh, maximum and the minimum measure ticks for the x and the y direction. See, it is ranges from 10 to 24. It ranges from 10 to 24, and then it means we have formed it as a square. And if we form the if we draw a diagonal to this square, then it simply means that if the data points are lying on this particular diagonal, it means we have a very exact kind of prediction. And if the data points are above this line, it means we have some over prediction by the model. And if the data points are lying below this particular line, it means we have some under prediction for the model. So this can be one type of scatter plot, and it may be of different types. This is just one type of scatter plot. So we will see the basic idea of drawing scatter plots is same for all kinds of data. We'll just see that how for this particular data we can draw this particular scatter plot. So let me go back to the Origin Pro platform. And the first thing that you need to see here is that suppose say here this is the x, the experimental hardness is in x, and here the predicted hardness is in y. So just let me select this, hold down the control button in the keyboard and select this also. So these two are selected. The x is the experimental hardness and the y is the predicted hardness. So let me go to this particular tab, the first tab, and here let me click on the, once I click on the scatter, so this is the basic form of the scatter that is being shown in the particular diagram. So if I want, what I can do is that I can double click here, and I want it to be in the form of a square. Same distances. I want it from 10 to 24. Here also I want it from 10 to 24. I want it to look like a box, as I already told you in the next class, in the last class, how to do that. We'll just go to the grid lines. We'll switch on the opposites. Now we want to have a diagonal. So we'll go to this tab and we can take a line from here. There are different kinds of lines available. Just click on it once and the line is activated. You can click on the endpoint inside and you can drag a line and you can click it here. A diagonal line is formed. You can double click on this diagonal line and you can adjust it as per your wish. For example, if you want to increase its thickness, suppose I want to increase it to a very thick line, so I can do it like this. I want it to be a very thin line, I can do it like here. And I want it to be a dashed line, so I can click here and I can have it a dashed line. Now, so what else we can do in this diagram is that if we want to change the type of the data points, suppose say here you see that two different data points are overlapping on each other. Here also two different data points are very close to each other. So in that case, it is wise to set them in transparent mode or give some hollowness in them or give some do not fill them. So let us go to here. What we do is that we just double click on any of the data point and it will open this particular tab, and we'll go to this particular option here, and here you see there are different kinds of symbols available. These are the solid symbols, these are the hollow symbols, these are symbols with uh, some small elements in between. These are so on, and these are half filled, half empty elements. So let me take a hollow element which is circular in shape, and let me click on apply. Since now here, what you'll see now, you see it is a little more visible, because now the second data point that is behind this first data point, that is slightly visible. So if you want, you can change the color of the data points from here. You can just click it here, edge color. You can go to the edge color, you can click here. By default it is always black. You can choose an individual color and you can click it. Suppose say I want it in blue. Let me click on blue and let me click on apply. So once I apply, it will look something like this. Now, if I want, I can increase the size of the data points from here. If I click it here, now they are more visible. If I want it more, okay, like this, you can increase or decrease the size of the data points. And suppose say I want these lines are now, the edge lines are now very thin. I want them to be a little more thicker. So what I can do, click here on this show construction, and now this is more visible to me. So here, what it is showing to me, this shape is circle and the interior is open. It means it is hollow. So what I can do is I can click on the edge thickness here and I can give some thickness to it. Suppose say I give 30% thickness to it. This is what it will look like. Okay. So based on your preference, if you make this 100%, it will be same as it will be almost same as a solid diagram. Similarly, if you give 50%, you can see, you can try out each and every one of them and see how best it looks for your diagram and how do you want to present it. Suppose say let me keep it this way. Okay. So this is how you draw a particular scatter diagram. uh, let us draw one more scatter diagram. Let us draw one more scatter diagram where we'll see this is the scatter with the diagram. Let us draw one more scatter diagram. Suppose say I want to draw this particular diagram, but I will show these are some scatter points. Okay, these are some scatter points. Each of the values, each of the exponent number have two different scatter points, and uh, they have some drop lines. You see, it starts from uh, 18 18 on this direction to 0, and then again from 0 to 18. Okay, basically these are like two different graphs combined together, but we'll see how we can draw them in one particular go. And there are some drop lines also associated with it. For example, in this particular case, I wanted that it should specify the distance of each of these data point from the mean line or from the zero line. That is why I choose this kind of graph. So basically what it tells me is that how far is this point from this mean line in the positive direction, and how far is this point from this mean line in the negative direction. Okay. So to draw this diagram in one go, we can draw it in two different diagrams and then we can merge them. How we merge them, we'll see them in our later classes. But here's a trick for you. If you want to draw this kind of graphs in one go, so basically the name of this particular parameter here is SI negative, and for this it is SI positive. But the value for this is also positive, but the value for this is also positive. Okay, the name is SI negative and we want it to be it is a measure of a negative distance, but in absolute terms it is a positive distance. And here also it is SI positive and it is a positive distance. So in this case, how I'll show you a small trick how to draw this kind of graph. I'll just tell you that this is a graph for the TOPSIS. There's a particular method called multi-criteria decision making. So there is a method in multi-criteria decision making called a TOPSIS. So this is a trick to draw the distances from the positive ideal solution, negative ideal solution in TOPSIS. So if anybody, I think this is a pretty interesting way of depicting the distances from the positive ideal solution and the negative ideal solution in TOPSIS. I've been using this in some of my papers. So I'll just show you how to draw them. So let me click it. Okay. So here I have the experiment number. I have 10 different experiments. I've conducted 10 different experiments and I have the SI positive values and I have the SI negative values. Actually, when I calculate the SI negative values from the method, I get them in positive, I get them as positive values, but for the sake of drawing them, I have added a negative so that I can form a graph. I can form a graph like this. I can form a graph like this so that I can form a graph like this. So I have put them in negative. So the next thing that I'll do is I'll select all of this together and I will go for a scatter plot. I'll click here and I'll go for a scatter plot. So it will look something like this. Okay, this is a different data set from the graph that I showed. This is a different data set and this is a different data set. This is for a different data set. So the graph may look a little different. So what I'll do is I'll just let me first close the box, or before even closing the box, what we can do is we can, okay, we first close the box. We can click on the opposite, we can click on the opposite, and this is how it will look like. Now we want another line in the zero line. So what we can do at y equal to 0, at y equal to 0, we can draw a line. So at y equal to 0, we have mean line here. Now we can go on adjusting this. So let me delete this part here, and similarly copy this and paste another one here, and I can uh, let me just double click on this. Once I double click on this, so here you find now an option of drop lines. It is drop lines. With these drop lines, it is showing the distances from this particular direction, but I want it in this direction. So drop lines. So now it is showing us the vertical drop lines. Now it is showing you the distances of each of these points from the particular mean line. Okay. Now the next trick is, if you want, what you can do is, if you want, since now this values are in negative, these values are in negative, if you want, you can change them. If you want, you can change them for this particular diagram. Or what you can do is that even after exporting this, you can use the paint and you can just erase the minus from here. So like this, you can draw a particular diagram, or a particular diagram in instead of in two parts, you can draw it in one part. Okay. If you want, you can like adjust the levels here. You can go to the increment 1. This was the how we draw scatter graphs. There can be different types of scatter graphs. Again, if you want to change the type of the lines or type of the color used here, you can just here and you can change the color and the symbol used. Here the symbol is specified, here the color is specified. Here, and you can change the color. Suppose say I want this to be blue and I want this to be red. So suppose say I want this to be magenta, I can, or pink for that matter. I can click on this, I can click here, I can choose apply, and it's done. So like this, we can change the color of the color in the different schemes by just clicking inside. Now let's see the next kind of graph that we prominently use in publications. Next kind of graph is a multi-Y plot. It is similar like a scatter plot with lines, scatter with lines. But here what happens is that instead of one y-axis, we have two different y-axis. Okay. So generally what happens is that some publications also have some page limit, and we want to specify to the page limit. Sometimes what we, instead of giving two different graphs, if it has the same X quantity involved, so we want to save some space in the graphs, and we, instead of giving two different graphs, we want to compress the information in one graph. But since these are measuring two different quantities in the y direction, so using one axis it is pretty difficult, or it would be disastrous to express them in form of only one y graph or on only y bar. So instead of that, we use two different y axis here. And similarly, in this diagram, you see that instead of one y-axis, we use three different y-axis where we represent three different strings on some experiments. For example, I've conducted 15 different experiments in on thin film coatings, and I have measured the hardness, I've measured the Young's modulus, I've measured the coefficient of friction. All of them have different units, all of them have different ranges. So I cannot express all of them on a single column or a single axis, single y-axis. So to save some space, I have merged all these three diagrams, but I've used three different axes here, three different y-axis here. And as per the axis, I have also changed the color here so that it is very distinct. For example, here the blue line represents the coefficient of friction. And whenever I'm looking at the blue line, I should look at this particular axis. Okay. Similarly, when I'm looking at the Young's modulus, I should look at the red line here, and I should look at this particular axis. So basically, this kind of graphs are known as the multi-y plots, multiple y or multi-y plots, because this is multiple y-axis. So let us try to make one such graph. Let's click here. Let us click here. So in this particular diagram, we have one x and two different y. So we'll select all of those. We'll go to this particular tab, and here you see there is double y. It means two different y-axis. You have three y. We have three y's. We have three triple y diagram where one. This also represents y in space and double y. It means on the left hand side there will be one y-axis. On the right hand side there will be two y-axis. Similarly here, in this case there will be one in the left side, one in the mid, one will be in the right side. Similarly, we can go on drawing for different number of axes. Up to 4 it is by default given, and if you want even for more number of axes, you can draw it here. You can use the multiple y-axis scheme, and you can go on draw for as many number of different y-axis that you want for the same x-axis. So let us draw this particular diagram where we have two y-axis and only one x-axis. Let me click here, the double. So now you see we have a very nice looking graph. What happens is that here this particular quantity that is measured in the black, accompanied with it this side is shown in the black. So its y-axis is this. Similarly for this particular data set, this is the y-axis. So like this, how you can make this is how you can make different kind of uh, graphs with having multiple y-axis. If you want, again, if you want to change anything inside the graph, you can click anywhere inside the graph on any of the data points. You can click here, and accordingly you can change the size of the data points. You can change the line thickness. Anything that you want, you can change it here. Similarly, if you want to change anything in the labels, you can double click here and you can change. Okay. Suppose say if you want this graph to be more convenient, so what you can do is that you can double click here and you can draw some grid lines. You want the major grid lines to appear, so it will look something like this. So it will be more easier for you to track. Okay. Similarly, you want some grid lines for this also. You can double click on this. You can go to the grid lines and you can click on the major grids. Okay. So like this, this is what you can do. Let us see a triple Y graph. Here I have specified the same information or the same data that I have here. I have specified is here. And let us see how to draw a triple Y graph. You can just select this whole thing. You can click here and you can go to the triple Y. So in this case, you see that one Y is in the left side, one Y is in the middle, and one Y is in the right. If you want, you can just click on this Y axis and you can drag it to anywhere you want. You can again increase the page size if you want, or even you can decrease the layout so that You can just drag and drop to decrease the layout. Now you can move it here, or if you want, you can move it further away. And for each of these individual lines, if you want, you can have the labels for individual lines. For example, if I double click, so let me so here what is showing you, this is the left line and this is the left line. If you want anything, suppose say this black one represents the hardness. Let me write here hardness and click apply. So you see now the label for this particular axis has appeared. Similarly, if you want for this particular axis, and since this is on the right hand side, the right hand side is showing as activated. Or what you can do is that this is the coefficient of friction. So just let me write COF. COF has appeared here. You see, this kind of graphs, if you would have drawn it in Excel, it would have been very difficult to draw it in Excel because you would have to set secondary axis multiple times, and it would have been a very tedious job, and you would have spent at least half an hour to draw this graph in Excel. But in Origin, you see that it takes hardly a minute to set up this graph and hardly a minute to draw this graph, just because we have a lot of inbuilt features here. We have a lot of inbuilt features here. So now what you can do is that if you want, you can close this, or if you don't want, you can keep it like this. So like this, we can draw this kind of graphs. Okay, so this is a triple Y graph. Let us move on to the next kind of graph that we have. Okay, the next kind of graph that we have is, okay, this is very important, interesting graph. This is called the normal probability plot. So we all know that what is normal probability. In most of our statistical analysis, we want our data to conform to a normal curve or a bell curve. It is a fundamental requisite for a number of different number of analysis. We want to see if the data that we have is following a normal curve or not, is following a normal tendency or not. So by using this kind of probability, by using this kind of normal probability curve, we can see if the data that we have is normally distributed or not. For example, in this graph, you see that this is a reference line. This is the theoretical reference line of the normal probability plots, and I have some data points, and I have plotted them as per with the reference line. And if you see that the data points are very near to this reference line, it means it is following a normal probability, a normal probability. Similarly, a more sophisticated version of this particular graph is this graph, where I have the same similar kind of information here, not the same data. I have a different data here. It's the same kind of information, but here what I'm also specifying is this confidence bands are there. These confidence bands are here. These black lines, this depict the confidence band. So you see that all my data points are within this confidence bands. So this shows that the data that I have is following a normal trend. Okay. So and this is a very good way to also conduct normality test on your data. And by default, you can also directly get the mu, that is the mean and the standard deviation of the data in the normal probability plot. Let us see how to draw them in the Origin software. Let us go back to this particular diagram. Okay, this is for the box plot. Let me go to, I don't know where is I have. Okay, it seems I have not uploaded the data for the normal probability plots, but it's okay. We can, with any kind of data, we can see, or we can test the normality of any kind of data. So let me take any arbitrary data. For example, go back to some other folder where we have number of data. Okay, so let me go back to this folder, the first folder that we have. Suppose say I want to see that the points that are being calculated by this method, are they following a normal probability or not? Okay, always remember that the normal probability plot, for calculating a normal probability plot, you need just one column with the values of the y points. So you need not have the x points. You need only the y points. So let me specify this. This is the y points that we have. We have 18 different points, and let me go to the statistics. And if you want, you can do the normal probability test from here. You can conduct the normal probability test from here. Or else, if you directly want to have a normal probability plot, you can go to the plot, and you can go to the statistics, and you can go to the probability plot, and you can click on the probability plot, and it will open a new tab. Now in this tab you can check the iteration of the data for different kinds of distribution. For example, if you want the data to adhere to a normal curve, if you want it to adhere to a log normal, exponential, variable, different kinds of tests you can do. So for example, I want to test the adherence of this data to a normal curve. So I'll just click on the normal, and there are different kinds of methods. Again, you need not know all these methods. These are different kinds of methods proposed by different kinds of researchers on how to construct a normal curve. So by default, it is showing us Van der Waals and graph, and let us stick to it and click on OK. So as soon as you click on this, so it gives you a nice, beautiful diagram. So this diagram shows that for all the 18 different points that we have in this particular column, are they normally distributed. So what you see here is that this point and the first point and the last point are somewhat away from the reference line. But other than that, all the other the points that we have in this particular column or in this particular data set are sticking to the reference line. So yeah, we can say that more or less the data in this case is following a very normal kind of curve. So or a normal kind of trend. So what you want in this kind of data is that what you want in this kind of normal plots is that you should not have this kind of data points, or we call them as the outliers. So you should not have these data points very far away from the reference line. If it is very far away from the reference line, it means that the condition of normality of the data is violated by this particular points. So in this case, since I have not drawn the uh, I have not drawn the confidence limits, so I'm not sure whether uh, they are within the normality bounds or not. But it looks okay. The data looks okay. Also, the origin calculates the value of the mu. That is the mean of the particular data set, and also the it also specifies the sigma, that is the standard deviation of the data set, along with the and normal probability curve. Okay. So this is how you can directly conduct a this is how you can directly conduct a normal probability test as well as draw the normal probability plots at the same time. Now, since we are already here, let me skip this box plot for a time being. Let me go back to this. Let me go over to the histograms. So in this histograms also, basically what histograms is shows that if you have a particular set of data, you just want to count the frequency or the number of times a particular data is occurring. So that is basically histogram. So again, in the histogram, here I have overlaid a normal probability curve. This is a normal probability curve or a bell-shaped curve. So I just want to see that if the data that I have is conforming to a normal probability curve. So there are two different ways to do this. One thing, I could have done it in this way. One thing, I could have plotted a normal probability plot like this, and it would have looked like this. And this next thing I could have done was that the second thing that I could have done was that I could have drawn a histogram, and then I could have uh, plot a normal probability curve on it and see if it is uh, conforming to the normal probability plot. So here, if I draw a normal theoretical probability plot here, and you see that some of the histogram peaks are outside it, and even the peak, instead of it being here, it is here. So we see that as per the theoretical, as compared to the theoretical normal probability plot, and there is some violation or there is some skewness. Okay. So the same thing, we could have drawn it by using this also. You could have presented in this way, or we could present it this way. So let me go back to the page where the histogram data is there. I think this is the okay, I think this is the histogram data that I have. So just let me again, for this you need to have the data in a y column, not in an x column. So let me go here, and on this tab you can go and click on the histogram. Otherwise you can go here on the plot and you can go to the statistics and you can click on the histogram. So once you click on this, so this histogram will be automatically created by using some internal beans. The beans have been decided, the difference between these 2 points and these 2 points. These are each of these are called as the beans. So these beans are being distributed or these beans are being pre-decided by the software itself. But if you want, you can double click on them and you can go to the data and the automatic binning, you can switch it off. And if you want, you can change the bean size. For example, here the bean size is 0.5. It means from 16 to 16.5, from 16.5 to 17, from 17 to 17.5, and from 17.5 to 18. So instead of 0.5, if I want it to be 1, I can do it like this here. I can give 1 here, and I can click. That the counts will also change. I have roughly 50,000 data in this particular column. So it is now showing you that this is the kind of trend, or this is the trend that we have for this particular data. So now if you want to see if it is conforming to a novel probability curve or not, what you can do is that you can here in the curve type that you have, you can there are different types of curves available. For example, I want to check if it to a theoretical normal curve. So I'll just click on the normal here and I'll press apply. So you see a normal curve appears. So if I want, as soon as I activate this particular curve, you see that an additional tab appears here on the which helps me adjust the line thickness. Let me make it a very thick line 5, and let me change the color for distinction. Okay, so now you see that I have a normal probability curve here, and the curve is starting from 10 and it appears to be continuing. So let me expand my series a little. Instead of this, let me make it 20. Now the entire normal curve is visible to me. So what happens here is that we see that this data is more or less normal, but it is not exactly normal. We see some violations here, we see some violations here, and we see a little bit of skewness here. The peak point, it is not here, but a little towards the left side. The same data, if I want to conduct a normality test on this data by using the normal percentile normal probability plots, I can go to the plot as we did in the last time. We can go to the statistics and we can click on the probability plot. So it will take a little bit time. You see that you see that since there is a lot of data, so by default the Origin has activated the speed mode. Speed mode is basically activated when we have a lot of data. For example, in this case we have 50,000 data. So to plot this, the Origin has activated a algorithm that it is called the speed mode. So here also you see that almost if we see from this point to this point, we see that almost 80% of the data that we have in this 50,000 data series are directly on the reference line, and some of the data is deviating from here and some of the data is deviating from here. The same trend, that is the same trend we saw it here, that some portion is deviating here, some portions are deviating here, some portions are deviating here. So these two graphs are complementary to each other. You can use any of them based on your need. You can use any of them to test the normality of your data or to display the normality of your data.